This question is testing your understanding of velocity time graphs, displacement time graphs, and acceleration time graphs. And it's a little bit of an extension from GCC, but there's not much difference. So displacement time graph, so it might have an ST, or you could sometimes have it as XT. Displacement time graph, then the gradient of a displacement time graph is the speed. So the gradient of that, if it was something like, I'm going to go with X in meters. So the gradient, dx by dt, for those of you doing mathematics who are confident with that, dx by dt, you can show as x dot, which is the velocity v. So mathematically, you might see it as x dot dx by dt, the first order differential. Then the velocity time graph, v in meters per second against time. That one, it's d2 x by dt squared, the gradient. That's x double dot, and that's dv by dt as well, which is an acceleration a. So the gradient of velocity time graph is an acceleration. We don't tend, we could, but we don't tend to do anything more with this. Certainly at A-level, we don't do anything more with this. With an AT graph, you could do the third order x triple dot, which is dA by dt, which is dv d2v by dt squared, which is jolt or jerk, and I don't even know what symbol it's given because I've never taught it, but it might be a J or something. So you've got all these different things. They're the differentials. There's the differential. You can just keep going. You can just keep going and get more and more differentials. Rate of change with the rate of change with the rate of change with the rate of change, and keep going and keep going and keep going. So that's how all those things are related. So that's differential, differentiation, differentials. Then you can do, if we won't do the xt graph, we'll do the vt graph. The area under that is effectively the integral of v dt, and that ends up with a distance. So you'll end up with a distance, a displacement. So effectively, this, you can think of it without going into the mathematics. It's this axis. The gradient is the y divided by x. So gradient is, you know that gradient's change in y over change in x, which in this case is distance divided, or displacement divided by time, so that's the speed. This one, y divided by x, is a speed divided by time, which is an acceleration. This one we don't really deal with, but an acceleration divided by time is a rate of change of acceleration, which is jerk or jolt. Then the area under the graph is the units are the y-axis multiplied by the x-axis. So if I multiply the area under a VT graph, multiply them together, I get a displacement because the units are meters. Then if I do that with an AT graph, of any shape I like, meters per second squared, then the area under this graph is a velocity. From that, I can look at the question. So which gives the same information? Gradient of a displacement time graph, that's a velocity. Area under a velocity time graph, that's a distance. They're not the same thing. Gradient of a displacement time graph, still velocity. Area under acceleration time graph is velocity. They're the same, so it's going to be V. Gradient of velocity time graph is acceleration. Area under a displacement time graph, I don't know what that is. It's something odd. Something measured in meter seconds. Not quite sure what that would be, although I could work it out, but it's not C. They're not the same. Gradient of velocity time graph is acceleration. Area under acceleration time graph is velocity. So they're not the same. So I'm convinced that only B is the same and the other three are different things.